Okay, this is video 2, part 2, just to go over question number 6 in the proofs practice for this. So I wanted to go over this one specifically, so I want to show you a couple of different ways to do these types of problems when you have perpendicular. So we're going to start with the given, just like we normally would. So we're going to have CM is perpendicular to AB. Put that in our first bubble. This is going to be our given statement. Whenever I'm given perpendicular or isosceles triangles, I try to immediately figure out what the final reason is going to be for the triangles, because that's going to dictate how much work I have to do with the perpendicular part or the isosceles part. So if I take a look at the picture off to the side, I'm going to find where CM and AB intersect, and that's going to give me my 90-degree angle. I know that that's going to give me two 90-degree angles. I'm just trying to figure out how much more I have to do with it. Okay, I'm going to go back up to the rest of the given statement that I just highlighted in green. So AC is congruent to BC. Let's go ahead and mark that in the picture. AC is congruent to BC. Okay, not doing the full-blown proof yet. I'm just trying to figure out where this is going. All right, so that takes care of the given statement. The only other thing that I'm allowed to do is to talk about this whole reflexive side. It's going to be right down the middle. So if I take a look at this, it looks like I'm going to have hypotenuse, so the green is marked, and leg, so that's side down the middle. So since this is HL, I don't need the two angles to be congruent to each other. I just need the two angles to be 90 degrees. So with that said, this one's actually nicer than having to do the other one. So I'm going to use this perpendicular business to then say, okay, the measure of, let's do the angle on the left-hand side. Let's call it AMC. That's going to be 90 degrees. And I know this because of the definition of perpendicular. Then I've got the 90-degree angle on the right-hand side, which is going to be the measure of angle. Okay, if I call that AMC, let's call this BMC. And that's going to be equal to 90 degrees. And so I can say that that is the definition of perpendicular as well. And then since it's going to be HL, which I've already decided, then I don't necessarily have to make those guys congruent to each other. So that's kind of nice. So figuring out my color coding or finishing off with that, we went ahead and said that AC is congruent to BC, and that's because it was given to us. And then the last little bit of information we came up with was that reflexive. So let's say CM is congruent to CM. And that would have been reflexive. Now, since this is HL, we want we want two of the bubbles to say exactly 90 degrees. That gives us a hypotenuse that actually exists in the triangles. Well, the hypotenuse ended up being the green side length. So those three things that we just highlighted represent the hypotenuse part of HL. And then the blue represents the leg that goes with this. So if we go through, we can now pull these together and say that triangle ACM is congruent to triangle BCM. And I'm going to kind of pull it off to the side here for purposes that I'm coming up with here in just a second. So this next part, I know that this is going to be HL, which means I'm going to use the blue bubble and the green bubble. And then I definitely need the 290 degrees as well. But I do want to think about, well, what if this was side angle side, or angle angle side, or angle side angle? If the proof was going to be one of those three, so let's say hypothetically, this would be a different proof. I would have my triangles here. So triangle congruent to triangle. Let's say the reason was going to be side angle side congruence, or maybe it's angle angle side congruence, or maybe it is angle side angle congruence. With these, it's not necessarily the case that we need the angles to be 90 degrees. we need the angles to be congruent to each other. So we would actually continue on with the whole 90-degree business. So I'm just going to color code this that purple color so you can see that, well, what if it was different? We would have to actually take these two bubbles here and pull them together and say that the measurements of AMC and the measurement of BMC are equal to each other. See, we're trying to get rid of that whole 90 degrees part. By doing that, this is substitution. So this process of we have numbers, okay, now let's get rid of the numbers and just say the measurements are equal. Okay, the reason why we're doing this, we're trying to get down to the fact that the two objects are actually going to be congruent to each other. So then we would say angle AMC is congruent to angle BMC. And the reason for that would be definition of congruence. Whenever you go from an equal sign to a congruent symbol, this would be the path that we would have to take to get those congruent angles for this if you have side angle side or angle angle side or angle side angle.